Good morning, everybody. Let's start our session. We're going to have a discussion about trustworthy AI and what is the best way of dealing with it, either by securely designing it from scratch or by evaluating and auditing AI systems in place. So the session is organized as follows. We're going to have two introductory short talks about the concept and some initial work that we have done. And then we're going to have some discussions on three different topics that are robustness, privacy and federated learning, and human agency in AI, and try to efficiently use the time slot we have to produce some meaningful results out of those discussions. So I will start first with my talk, which is Trustworthy AI, the title of the talk. I'm the coordinator of ENFIELD, which is one of the latest networks of excellence, one of the three of the last generation of those. And in the context of our research, one of the things that we do, between other, is a research pillar that is called Trustworthy AI, and is related to all the discussion that we're going to have today. So for me, it's a bit strange because I have been a cybersecurity scientist for my life. So for many years, I've done things like secure by design, risk assessment, risk treatment, verifiable operation of computer systems, and monitoring of the operation of systems to increase situational awareness. So this has been my life until 2023. And then I got the opportunity to coordinate ENFIELD, which was a big AI project. And I found that very interesting because I thought that this was my opportunity to jump upon the wagon and do also research in AI and LLMs that everybody is doing. So it was a very exciting opportunity for me. But as the project started, I ended up doing security again, because one of the main topics in AI, the security of AI systems, trustworthiness of AI systems in general, which includes things like how we make our AI systems more secure, how we deal with privacy when we're talking about AI systems, privacy of data, privacy of models, how do we establish trust when we are using AI systems, and how we can integrate such components, AI components, into critical systems, and how we can conform to standards and regulations that have started coming up about the trustworthy use of AI. So more or less, I ended up at the same point, trying to do the things I've done before with traditional computer systems, but this time with AI. So why this happened in AI? The main reason is because AI, the form of AI had changed. If we had this discussion 10 years ago, AI was about me and my PC, having my data in my PC, my model in my PC, doing the training on my CPU, and actually getting the trained model and use a new chunk of my data as well and do the inference stage of the AI life cycle. So everything was between me and my PC, and everything was controlled from me, from a single actor. So at that point, trustworthiness of AI was a much easier goal to have. But as the years evolved and we ended up having much larger models, large volumes of data, much larger models, a lot of high requirements with regards to resources in order to train the model. So we ended up having more or less the same thing, AI systems, but in a distributed format where I have the data, someone else has the model, someone else has to do the training, someone else is going to use it. So this distribution of tasks has created an issue of trust, and now we need a technical way to establish trust between those entities. So as we moved towards this new scheme of doing AI, we started worrying about privacy of models, because nowadays there are models that are closed source, you cannot access them, you just use them remotely. Of course, privacy of data that are used to train the models. Integrity of the data that we use, we need to be sure that the data we use are in the proper form in order to have a good training of our model, but also integrity of the operations during the training or the inference with models. So we have to be sure that the process that runs behind the curtain ChatGPT, for example, is what it should be, and nobody's cheating on us. And at the end, we need to be able to have trust in the AI functionality that we use in order to integrate this into other systems and use it for different purposes. So back when I was doing cybersecurity in general, we had a number of steps that we followed. For example, identify what are the issues, the security issues of your system, try to protect the system, try to detect what happens when it happens, if there is a security event, try to respond to that, and then try to recover. And the first discussion is this cycle good for AI systems as well, or we have to adapt it, change it? It seems that most of the things here are relevant, maybe not in the same order or with the same importance, but those are all relevant. If we try to see why it's difficult to do this discussion, to have this discussion about AI, the main reasons are we need to find a way to measure risk. We are measuring risk in traditional cybersecurity with a number of ways and methodologies. We need to refine those methodologies and include AI risk measurement. We need to find ways to support the AI systems in order to be able to tolerate risk, in order to have to somehow mitigate attacks and problems and have the system operate as it's expected to do. There are cases in which we are not able to mitigate every risk, so we have to do risk prioritization, which is also a difficult question to answer. I'm more happy having my data, my training data leaked, or I'm more happy having my model producing biased results. And finally, it's difficult to integrate this AI security trustworthiness discussion in the general discussion about security and trustworthiness. So you don't have an AI system on its own. You usually have an AI system that is a component of a larger system. So you have to integrate the discussion of risk about AI in the general risk discussion you have. So what actually is trustworthy? What do we mean if we say that I want my AI system to be trustworthy? The first thing is that I want that to be valid and reliable. I want that to be accurate, to be reliable, to always operate with the same accuracy, let's say, and to be able to adapt to new conditions and new data. Because we tend to use AI components in critical systems, we have a safety requirement as well. So given that I want to integrate AI in cars, planes, or whatever, I need to be sure accident that will have not wanted results. And in order to achieve this, we need to, apart from developing the system, we need to do a lot of simulation, in-domain testing, and real-time monitoring. And we also need to be able to intervene when it's required. Then, of course, we need to take into account cases in which you have the presence of an adversary, you have an actor that really wants to make your system misbehave or be not accurate enough or whatever. So we need to protect our system against such attacks with additional training and every other technical means that we have. We would like our systems to be accountable and transparent. Transparency is about having information about how the AI system operates and how it produces its outputs. This is not always feasible, mainly nowadays where we have this remote use of large models that we don't see. So it's a thing that we have to discuss. And accountability is about really being able to identify what went wrong when things are not working properly. Another thing that we commonly discuss is explainability and interpretability. It's about being able to represent mechanisms underlying AI operation and also be able to interpret the results of AI systems and understand why the AI system says this and doesn't say the other thing. And also, we have to take into account privacy and first of all, understand the privacy risks that we run when we share data with others that train models and what this means for our personal data and our privacy. So we need to have privacy-aware handling of data and models when this is the case, and also try to use technological means like privacy enhancing techniques or federated learning in order to increase privacy in our systems. And the last thing that is also discussed is fair. The system has to be fair when it has as less bias as possible. Bias can be found in datasets, can be found in the way we are doing training, can be found in the way that humans interpret the results of the AI system. So we need to ensure that our AI system suffers as less bias as possible in every possible way. So in order for us to achieve this goal, in order for us to have a system that is more or less close to those points that I have mentioned, we need to have a strategy. The truth is that AI is changing a lot. Things are moving very fast. If we have this discussion 1 year from now, probably we have to say and discuss different things. Technology is still maturing, so it's normal to have a lot of issues. So from our side, as the AI community, we have the option to either make systems that are safe and secure by design to the extent that this is feasible. So we need to plan in advance. And when we create, when we train, when we deploy our AI models, we have to make them as secure and as safe as possible. And the second option is to try to evaluate, audit, monitor the operation of the AI systems even after they are deployed, even after they are in place. Probably the best is to combine both, because even if you try a lot initially to have a safe and secure system, it may not be as safe and secure in the long run when data changes or whatever. So the discussions here today are mainly about what are our options in terms of these two approaches regarding 3 different topics that we will mention later on. And we would like to have some good discussions and some interesting results out of those discussions about these points. So that's all from my side. Ernest will give the next talk. We can have some discussions now, but I would prefer to have the discussions at the end when we have the input from the co-working activity. So let's move to the next talk. And
this one?
This.
Okay.
It's okay. 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 So thank you. Well, my name is Ernest Baldain. I come from the Computer Vision Center in Barcelona, Spain. And well, we are members of the ELSA Network of Excellence. Well, I will try to explain a bit the approach that ELSA Network follows to approach some of the topics that George has commented on trustworthy AI, just as a way maybe to raise some points for discussion later on. Actually, I'm not an expert on secure and safe AI. Our expertise is more on computer vision and multimodal models combining vision and language document understanding. And we came here to this project just to integrate this component of privacy, robustness in all the steps of the document understanding process. So more from the application side of the topic. So well, I will try to summarize a bit what we are doing in ELSA about these topics. As I said before, just maybe a way to start some discussion points. The main motivation or the starting point is the contribution to this trustworthy AI vision of Europe that has many aspects to take into account. And the ELSA network tries to give an approach to some aspects of these aspects related to trustworthy AI. Basically organized around 3 grand research challenges that are more or less the 3 topics that we have here for discussion. that are robustness, privacy and federated learning, and human agency or human in the loop in the decision-making process. So these are the main focus of the research in the ELSA network, and this is well done through a rigorous methodology and foundations on all these different aspects of research, such as well the differential privacy, explainability, interpretability, federated learning, in general machine learning and deep learning. One of the points of the network is the definition of these 6 use cases that later we'll explain with more detail, that try to bring the outcomes of the research more theoretical foundations to practical applications in some fields that can be relevant, where privacy, interpretability, explainability can be relevant, such as health, autonomous driving, robotics, cybersecurity, multimedia analysis, and document intelligence. The use cases serve as a way to take the outcomes of the research to practical applications, to put in relation different communities, communities more focused on computer vision or machine learning or language understanding, with the community of trustworthy AI. And they are organized around different benchmarks that can also be used as a way to evaluate and validate what we develop in terms of research. One of the important the topics that George has commented before is the evaluating and auditing and validation. So maybe use cases can be a way of doing that. Of course, it is important also to take into account community, not only technical aspects of this, but also legal requirements or all the ethical aspects of these topics. So skip this. In the strategic research agenda of the network, there are several points that are the basics for developing the research, and the work of the network is basing on a good analysis of the threats and the risk that we can have, not just an empirical analysis, but also try to get good theoretical foundations about the models of threats and risks that can get then better analysis, and also try to find formal warranties and insights on the limits of the methods that we are using, taking this interdisciplinary aspect, working not only from the technical aspect of view in the secure and trustworthy AI, but also with other fields such as cybersecurity or more machine learning community, but also community from the legal and ethical world. A global view of the whole chain of implementing an AI system based on these ML trust operations that goes from the data preparation, training, validation, deployment. So try to integrate all aspects in trustworthy AI in all these aspects, taking also into account governance and legal aspects. And also important, trying to get an understanding of the, sometimes we have several trade-offs when we use privacy or explainability, interpretability between what we are able to, for instance, to protect in terms of data or the utility of the method. So try to understand this trade-off, and then, as George has said before, try to prioritize which is what we more important in every application. So going a bit on the different challenges that we have in the network, and the approach that we follow in terms of research in each of the topics, starting by robustness. Not the starting point is that we see that most AI methods, like some robustness warranties to out of distribution data, to attacks that can be done to the systems, and so we need new methods, more robust and methods that can certify somehow this robustness. No? So we identify as a challenge this point of finding the certification of the robustness of the methods, and also scaling to more complex models and systems as the models and the use of the data becomes more complex. It's maybe more challenging to get these robust methods. So the goal in the ELSA network is not only to improve robustness, but also work on how we can certify this robustness and measure the limits of the approaches, and try to do this certification. From this point of view, the work is divided in these 4 different tasks or goals. Basically, finding methods to be able to do some evaluation of robustness, and develop new methods that can be also certifiable in terms of robustness. And another point related to uncertainty estimation. This is not being able to estimate the uncertainty of a prediction to help in the decision-making process. This is important, especially with out-of-distribution data. And also take into account the relation between robustness and the other topics addressed in the project, such as privacy or explainability and fairness. From the point of view of privacy and federated learning, the starting point here is, we are using a lot of data to train our models, and these models are based on many times on private data that can be leaked if we do not train it accordingly. And so while we rely on the state-of-the-art technologies for this privacy preservation that are basically based on federated learning to avoid communicating data between different actors, and also differential privacy to get some formal warranties of the privacy that we can have in our models. But while the main challenges here identified is that many times there is a gap between the theoretical upper bounds that we can get from privacy and the actual privacy risk that empirically we can measure, and also scale these models to more complex models and networks that can still be efficient and keep the privacy. So the goal here is to advance in these distributed learning and privacy technologies in a way that can maybe close this gap between the theoretical bounds and the utility, and can be scalable to larger models. So we are in the network developing algorithms for this, advancing this collaborative federated learning, and also analyzing this relation between privacy and utility, and try to get this trade-off between privacy and utility, also integrated with federated learning, without forgetting the issue of efficiency and scalability to larger models, and to reduce the communication bottlenecks that we can have in this kind of models. And for the challenge of human agency, or human in the loop decision making, we start from a cross-disciplinary point of view that we need this relation or communication between technical experts and legal and governance experts to be able to embed these technical methods with all the governance regimes that to be able to deploy these trustworthy models. And so here challenges from the point of view of the network are in the way of developing better models that can be interpretable and can be explainable by design, and the interaction between the IA system and the human, the context with the humans and the human oversight of the systems. So in the network, we work on different forms of developing models that can be that can give some explanations for the decision-making processes and methods that can be interpretable by design, and also we investigate third-party certification and accreditation for these trustworthy AI models and integration with all the ethical and legal governance aspect of the models. This is basically related to the research challenges, and from an application point of view, this is implemented through 6 different use cases in health, autonomous driving, robotics, multimedia, cybersecurity, and document intelligence. For each of the use cases, we have identified some of the 3 topics that can be more relevant to the use case, and the use case is focused in 1 or 2 of these challenges, but it does not mean that maybe we can also apply different methods from the other topics also to the use case. Each use case is led by an industrial partner that can help to take the outcomes of the project to real applications. And well, the use cases have to be useful for that, to take the outcomes of the project to a practical side. Well, the use cases are basically organized around different benchmarks, and the benchmarks can also be used to do this validation, certification, evaluation of the research in privacy, explainability, federated learning, robustness, so that we can have specific evaluation tools for each of the topics in different application scenarios. This is a bit a summary of the specific topics that are covered by each of the use cases. In health, it's more about medical data. In autonomous driving, the use cases focus on segmentation and object detection and based on robustness of the methods, segmentation and detection methods to different out of the distribution data. In the case of autonomous driving, this is highly relevant. In robotics, using a simulator, the benchmark is based on robot planning and human interaction with the robot, based basically on privacy and interpretability, human agency. For the multimedia case, the challenge of the benchmark is organized around deepfake image detection, and based on the explainability and interpretability of the methods that are developed there. In the case of cybersecurity, in malware detection and on the challenge of robustness against different attacks, future attacks, or space attacks, or the data evolution along the time, the change in the data distribution. And in document intelligence, we focus on visual question answering on documents, answering questions from documents using multimodal models. And here, the challenge that we address is basically privacy, how we can protect private data that we have in documents, sensitive information that we have in documents, and we have in a blue-red team scheme based on federated learning and privacy, federated learning and privacy. Interesting point, I think, to let you know is that this is all organized with a platform where all benchmarks are integrated and can be used as a common platform to access to all the evaluation, certification, and validation tools that we have for the project, where all the data is there and the methods can be submitted and can get automatically evaluated, so we can get with this state of the art of the different methods. And well, commented maybe in the talk before, we are integrating this with the more generic AI on demand platform. Okay, well, this has been very well somehow successful since the creation, and well, I think that's more or less all that I wanted to know, to explain a bit our approach from the ELSA point of view to this trustworthy AI. Okay, that's it. Thank you. Okay, so
sorry to move on with the activity, but proposal. The Excel plan was to have 3 groups going around. But we're not too many. Maybe having an open discussion for each one of the topics is better.
I think yeah.
So present the topics and
yeah.
yes,
Yeah.
yes.
Yeah.
It's not more like this though.
It's this.
It's this.
Yeah.
So there's also one more.
Yeah. Yes. Yeah. Yeah. It's this. Well, here we have the names who were leading the discussion, but I think it doesn't matter. Yeah. Well, these were the topics. I think the topics that we wrote here is just a starting point for discussion. Just to raise some points to discuss, but maybe we can open to other things that maybe are not in the specific questions. This we start with robustness, yeah, or yes, or we'll.
Someone has to take notes, so
Yeah.
you can. So that's yeah.
Okay. So, well, maybe I can list the questions, yeah, and then maybe we open the discussion. In some of the topics, if you want to add something because you wrote that, just feel free. Yeah. Yeah, and one thing is, what are the main requirements for an AI system to be considered robust, taking into account different types of robustness, out of distribution, adversarial attacks. Yeah. Then also relating robustness to European regulations, how these regulations can support or facilitate the deployment of robust AI systems. If robustness is more a matter of safety or security. Are there any good general practices for making an AI system robust before deployment in advance? And on the other hand, if there are good practices for testing the robustness of the deployed system post-op. Yeah. And then the trade-off sometimes that we find between robustness and utility. Yeah. Well, that's what the points that we had. So
how we're going to we can raise our hand and answer this question. Would like more?
Maybe this is a starting point.
Enough time for all
Yeah.
the answer. We can choose questions.
Okay.
For the regulations, my question would be then, is there anybody among us who have read at least the main documents about the EU or the US regulations? Is there anybody who read the 420 something?
No, I took a look at the robustness section, but not the entire 400 pages.
Gone through it, scrolling. I'm sure that this is a thing. It's too much information to consume. It's difficult to use, probably it has to be so lengthy, but it's difficult to use in the first.
Well, I know that at least in Hungary, there are a lot of law firms who are just working on giving insight, however, 2 hours. So that would be a useful part for the AI quest to put together maybe for different lines of what should be known. Because when we are talking about competitiveness, I think the typical startups of, let's say, between 5 and 25 don't have the resource to consume more than that. Even academics are myself. So my recommendation would be that to have an environment that like maybe the details is 420 pages, but at least there should be like a summary or something which is not more than 40 pages. Otherwise, it just goes to the legal people and the engineering guys. They're just very superficial experience. And then we are in trouble, example, when we have to review a project. And then is the question whether like this cross-third concepts and so on are properly handled. Then actually we, at least from a strict point of view, we are not knowledgeable enough to judge that thing. From a normal average person in the street, yes, we are probably know more. But if you are taking a legal point, then I think even as experts, we are in trouble.
I mean, that's the other point, even if you go through all the 400 pages, knowing what that actually means in legal terms is not another thing, right? Because so I went to the robustness section actually of the EU AI recently, and they often say things like take all reasonable measures to ensure robustness. Well, does that actually mean? Or employ state-of-the-art methods? But what's the definition of state-of-the-art methods? So.
Yeah, I think this is why it's important that in this kind of networks we have people from different disciplines, to get a common vocabulary between the legal people and the technical people, because you don't have the time to read 400 pages. If you have a summary of 20 pages, but if the language is also very legal, maybe we will not really understand what they're meaning. No, we will not be able to find the relation between our technical part and so maybe we need to find this common language where both legal people and technical people can meet.
I would propose that it would go, for example, on sample use cases. That would be much easier to understand, like, which industry.
I have another question actually for the requirements. I'm not coming from a robustness background, but when I think about AI, when I think about robustness tools like Hammer, I assume it's something that has a timeline. I use the Hammer, over time it doesn't start to break. To continue to use it. And we have these discussions about language models in particular, having a feedback loop intrinsically and the text generated by AI at some point being fed into their training again and the quality potentially going down. So was wondering whether this time dimension, let's say stability over time, is considered a robustness requirement, whether it's covered or haven't been.
If you want to give the robustness over time, if you have a specific model, you train that, you have a specific kind of data that you feed to that. It's more or less easy to have it as a robust model. But if you have this LLM story that you keep getting the output, creating web pages or information, getting that into the input, they cannot doing this loop again and again, this may make system LLM to something that we don't want to do in the long run.
An area where I know that this is a big issue is in cybersecurity, because there you have this natural loop between defender and attacker. And it's also an area where people have tried to use machine learning a lot. And there are just time components always critical, like this involvement over time to different attack pattern actually means that usually we have to do like continuous updating and training of these models. So definitely made it. Okay. It's really old.
Is it better now?
Can we somehow make the people online visible to us? To include them in the discussion?
Yes, this is with the WebEx. Okay, can you put the other participants?
Yes, I sent a question in the chat right now.
Maybe we can stop the sharing and we put them.
They can see the slide. They can see the slides. It will be good to copy from the
Yes.
yes. Here they can see the slide, but let's keep the volume.
No, the participants for this one here show the.
In any case, they see the panelist and the speaker. So
Yes.
okay.
Not,
If they want to give us an input, they can chat. Okay. So you're gonna advise.
Yes. So yes, one important aspect obviously is control of the data that is fed. It's related to the stand dimension, to the decay. And I think in the AI Act, a strong emphasis is put actually tracing where the data comes from, having full traceability. And I guess if you're able to technically put that into place, then probably you could much better control this issue of safety that could be caused by data that inadvertently is fed inside the system. Then obviously the question of how you enforce that. I think for all the industrial aspects, probably data spaces have a strong role to play in that. But then in terms of research, I'm not quite sure what plays this role, because data spaces are clearly oriented towards industrial use cases, but not so much, researchers and academic experiments. I mean, there is some need of federating platforms to actually enable all this, to make because, well, there are tools that do those things.
I think I have to show you that, to be honest, if you go like with the search in my help, you can find like salaries in people is simply like mixed. And everybody please now we can help that is the one ask where is going to be right, and then you can find again this new better, but there's nothing more. So I think a huge issue for actually having in the know and for the next is that we don't know what because we need to have information there.
I guess this is related to life cycle management, because for data now, when you're doing data management planners. You actually have to plan for the creation of the data, of the disposal of the data, sustainability, all those things. This is not something we're doing with AI models or foundation models. People just train them, dump them. Okay, there's some metadata, but it doesn't cover all those aspects. And I think this is also something very important, because if people don't make the effort of actually documenting, those aspects, then you have no way of knowing, and then indeed maybe you're using some knowledge that are no longer relevant. But yeah, the platforms that actually serve the model should have a way of telling you, oh wait, this thing is outdated, or there were some issues that were pointed out. Maybe use this one instead.
For me, it's too hard. It doesn't provide the technical means to do what they want. And there are technical means that I find online, but again, you can have, is this the right one? If I do this, okay or not? So, well, probably because of the technical complexity of the discussion, it's difficult. This tool, we put like it, everything is good. But we need some guidance for us that we research, not for companies that don't use AI. We want fast and good solution. How can they be sure that, okay, maybe I'm not 100% okay with the AI, but I'm in the right direction? They can. It doesn't have a list of things of wishes. At least it could be like that. And then a broad range of technical solutions that they have then to do on their own is finding of solutions. Maybe we need to provide some more help in that context.
I guess the reason why I don't want to do that, at least not in the game, so because of the books that I'm so should we say that I'm a big event and then that's where we need to go again. But that's for sure. I think these are the pronouns to
and I think we have how we put this snapshot this framework of security resilience.
Yes, in safety.
So we were discussing what can we do for this task in the project that would be useful for the community. We ended up by providing some tooling, some way to use the AI. For example, to answer some questions and pick parts of the that are relevant to your case.
Or what are the standards to it?
Make the process easier to someone to the extent that it's people have. These bullets for me is that the second for us about the robustness, and I think it's we're not good research-wise. Because we had happiness and that also actually, but if the visual results, I think have one outlier that should make time for example. I think that's so this is it gives this some experience testing and silence, but I think people are moving in this direction. I mean, there are things out there that it's not always strong. It's been because of the nature of subsystems. They're not deterministic. Yes, we have a right way of operation. But we cannot see it, you cannot check it. So in ENFIELD, we have Boeing as well. And we were very happy to have Boeing, and it will be very good. And what people from Boeing say is that engineers from Boeing, we are not allowed to use any AI on the aircraft because of the validation process that we have for any software that we use. It's very, very rigorous. They go through every line and prove that this will work like that in every possible case. You cannot do that for AI. You can do that for a computer program and say these are the different inputs and these are the input outputs. So in every combination, this is okay. But then you cannot do that for AI.
I mean, there's some methods to try to do that, like simplification, we try to apply all methods to different networks. I guess the problem that I'm studying is the survey. So insights were done. to the analysis. Okay. And compared to the elaborate ones on these ones we have today, that's very almost disconnected. Which I guess thanks to the last point kind of is about essentially we have some systems where you can do this, but they are very small subset of the systems European elements which are capabilities. But I guess the question is how much utility are you going to have on some capabilities.
With this song, they didn't where member names just immediately the next slide state of that. We very have like exact confidence in the lots of evidence as like condition they work with power if you can say something about how one
Yeah.
Thing is, I think in the methodology, there is actually methodology to prove whether model is robust in terms of generalization, in terms of many aspects. But the thing is, with those large models, people don't do that anymore. In the conferences, even the evaluations, okay, they do some evaluations, but they don't repeat the evaluation multiple times because it's not deterministic. So normally, what you would do, you run it 1,000 times, then you observe the behavior, then you do error analysis and such things. But for a very large model, you cannot really do that, and so that's really a challenge.
Or it will take.
Yeah, you can do it, but there's also the question of the resources it costs, the environmental impact and all that. But in the past, the rigor level in machine learning conferences, for example, in terms of how to properly evaluate a model really went down because, people stopped doing cross-validation and all those things that, have good justification for having been imposed in the past. And now, well, we're not doing it anymore. Okay, we're doing something that tries to limit the issue, but still, it's really not at the same level.
So we move to the next topic because we don't see we have time.
Okay. Well, we had questions, but some of them are also similar, but for privacy. Terms of technical challenges, scaling up privacy guarantees to complex and large model. I think it's similar to what we have discussed about the robustness. How do we assess the privacy guarantees of the models that we deploy? Or given the privacy, one specific topic could be that of large language models, foundation models, and we can address privacy training these very large models. Or then we can have specific privacy threats in some application domains that can be more relevant than others. It can be a very relevant domain for this. And well, what and similar to before, we can align privacy from a technical point of view and level of regulatory point of view.
I want to start with the other elements that most regard as the living setback. I have the phrase in title patient rights to say the original degree. I mean, as a restriction. So, I get the very straight and confirmation tax, which is basically additional value. This is good enough. How do I
Yes, one aspect that we were trying to deal with in a project on information detection was the collection of data for training models for different types of fakes from the wild, from online videos or in cases of fakes, debunked fakes, etc. And to use this data for. So the question was if this data contain personal data, data that can be used for identifying persons in the background of the video, persons crossing the road, while the main subject is in the front of the video. Our DPO, they contain personal data. So we need to do statements, overstatements, and sign papers that we collect personal data and we deal in this way with this data. And this is a very process. Our impression was that given that we need to train a classifier, not for face recognition, person identification, etc., but just for example, for sensational content detection. If this content is visually disturbing, not targeting which persons are included in this. So again, the answer was yes, you deal with personal data and you deal with privacy requirements, and you should formulate specific actions for the security of this data, for the management of this data, etc. So this is an ongoing discussion in the project. We have also a legal expert which provides us with some 15 documents to sign, and different documents to sign. Yes, it's a bit challenging for researchers to address these issues. To a certain degree, yes, it's doable, but it's not feasible to take into account all the different topics and say that even despite the fact that I'm training a general classifier, I'm dealing with personal data and have to follow these regulations about the management of this data. So behind all these nice questions, in my perspective, we need to priorly specify what is personal data in such videos or images. This is a difficult question.
Yeah. But I'm not sure if we can deal with that in terms. I mean, there is the GDPR right now, so GDPR defines what personal data is. What you described, for example, is about the scope of processing the data, which is part of GDPR. But the collection is something else. So I don't know whether it is feasible to have something separate, specific for AI, for example, models or something like that, or if we need to follow this GDPR, and try to combine those.
Most probably we should follow guidelines from GDPR, because applying processes for anonymizing such data would fail the training process. Anonymize faces in a video for training a classifier, not much make much sense. Or you try to train a fake classifier. Most examples are from well-known persons, politicians, etc. These are personal data. You have the fake image of Trump. You have Trump. It's identifiable. So you cannot apply any anonymization on this image. You just block the training process.
I guess one of the challenges with machine learning in this case is that you necessarily make the information from the data into the ones. And if you train it on like a very benign or non-sensitive task, you'll always learn sensitive features in some form. That's very easy to misuse for different purposes. I guess not, it's actually quite easy to do. Change the fuel of the model, for example. So yes, I think that's this privacy concerning that can be used to misuse the information from the data. So I guess that's a big challenge that maybe more traditional stuff processing our data, which doesn't allow machine learning. They can increase the like a little bit area, but it maybe was It's one of the ideas of different requirements to some of
It is good for leader. If I see for the leader, a person that passes by a vehicle, I would have. Even if I was the passer, even if I would break the someone could identify if I was in the background of a big vehicle to train this model. I wouldn't have a problem. And then perhaps. But the thing is that the regulation happens on a different level. They cannot come at us. If I wouldn't have just said. And probably some other wouldn't. So they have to draw a line at the level that we can tolerate. That's what they
yeah, so draw different lines. For example, you guys like like being a background view. I think some states don't get it yeah. But they tend to be a little more open than saying to go public. I think they can be. To the data can be this.
I'm still happy that you had some DPI, but I recognize I'm happy that was just place. You don't have many sounds that are but then again, we have to deal with at least as a center, as companies, as and this not only on the visual domain, because this information detection involves a lot of social media data processing, where you have individual social network accounts working as groups for spreading this information. So all this social network analysis involves heavy amounts of personal data, actual personal data, because they can lead to the person behind the account. In our project, we apply a level of anonymization, which can allow training text analysis systems, because the goal is to extract semantics from the text, not the person behind the text. But when the aim is to identify specific data sharing practices for spreading this information, then you have to deal with groups of people. A level of anonymization can also allow to model these behaviors without thinking who is behind these behaviors. But again, it makes things harder.
All this is point out for data collection, data organization. Then, of course, once we have the data, we train a model, we want to comply with some privacy guarantees that we are not linking with private information. I have the feeling from my limited personal experience with privacy that we are very far away from being able to deploy real systems that can have a good agility and can have good privacy guarantees. So if we have to comply with these deployed real systems, I think we are very far away from the technical point of view. So as before with robustness, but the models that we can deploy are very simple, the same with drivers. So maybe we need a lot of work and effort trying to scale up this more accurate and
something I find very interesting is, I think that concept of robustness and also privacy, that if you actually want to guarantee proofs, then we often have to things, and it's sort of basically be more conservative than actually would have to be in practice to get computation and use of computation and more sensible. If we use these techniques, for example, foresee, and just do a little of that. It's not enough to prove any values. Can often be that empirically the models get already way better in terms of privacy and robustness. So we might not have these market guarantees, but empirically maybe they are much more severe to see our robustness than access. I think I see a lot of uncertainty in the discussion. That's kind of expected, especially with regard to how to translate the regulations into technical solutions. So I wonder whether this might be the right point in time to reach out. We are not the only persons doing AI, right? To the other researchers, at least in the European Union, maybe via the enemies represented here, asking how do you guys deal with that? Because it might be a good idea to start assembling at least a limited set of best practices. Someone must have come up with some solution. You indicated that you are doing certain things for vision-based training. I guess it's an idea to start that work on having a set of some best practices, someone to translate GDPR into technical solutions. Otherwise, everyone independently tries the same thing. They're all struggling. They're wasting a lot of time. Maybe a follow-up.
So maybe the idea is to start writing papers from the industry. Let us basically research, know what is going on and try to the stuff, something like that. Yes.
I suppose it is hard to get speak to our end. But it's
Maybe someone should propose a cost action about that because that's precisely the purpose of such things. To write best practices and recommendations.
I guess if you look into more mechanical engineering, the lots of industry maps, one of the that shows basically are the state of the art. Well, find the state of the art as well. The mode bound system, because it's very intransparent and you have to pay for everything. But that's at least some great so there you are. Adjustments. Yeah. Okay, well, the questions very similar in terms of technical challenges, what we need to these interpretable by design models, benchmarking, and verification in terms of transparency, explainability, and large language models, cognition models. What we need to deploy real explainable systems, the alignment between technical and regulatory aspects related to this. Though in terms of this, well, we have talked a bit more about the AI Act, what it defines, so not this small language, risk levels come with translate into technical aspects. Well,
in one of your slides, I think there was some information about benchmarking explainable defect detection. Is this an output of the ELSA project?
Yeah, this should be on the benchmark platform that I have shown with one of these slides. I can share with you later. There are all the details of the benchmark and the data and how they address explainability and how they evaluate explainability from this specific benchmark.
Okay,
I don't know the exact details, but I know that they are this is public and probably they have already realized some operation and some.
Okay.
That's right.
I will probably check this because we also try to tackle this explainability in defect detection aspect, which is a bit more challenging than the classic image classification problems. Because when the usual perturbations from the input classifier to assess the impact on the outcome, the output of the classifier, I mean for removing specific regions of the image or adding blurriness, noise, etc. In the case of deep fakes, they lead to misleading results. So there might be the chance that you add a region of a facial region of the deepfake image, and you increase the classification accuracy rather than decreasing. So we propose an idea of adding adversarial noise of the image that have a similar behavior when with the classic perturbation processing using classifiers. And we also propose some evaluation protocol, some evaluation framework, and assess the performance of a couple of 4 or 5 different explanation approaches for perturbation, for model agnostic and one model specific. But it's a hot topic. It's a very challenging task because it's completely different from the classic typical classifiers, the deep classifiers. And I think there's a lot of room for further investigation within that direction.
Yeah, I think that the topic benchmarking and evaluation topic that maybe it's not easy to identify.
Yes.
We are also when working in the project in the use case of global understanding that I have shown on, we are also trying to address some very explainability of the methods, not by we get a specific answer to the question, and it's not easy to define how we can evaluate this explainability related to the methods. And then we need also.
And also, in my perspective, there is no strict line between explainability and interpretability. I think Yorgos before made a nice distinction, but in my perspective, it's sometimes the AI is kind of framework. I'm not sure if it's right, but okay. Because in a couple of works that we provide explanations for deepfake classifiers and video summarization technologies, it's kind of interpreting what the visual explanation shows. The level of detail might lead to an explanation or interpretation of the output. I mean, if you have a specific visual object demarcated in one image, then you can say, this is an explanation. This affected the output of the classifier. But if you have a visual mask, like a heat map that indicates the region close to the mouth or the eyes of a deepfake image, then it might involve a bit of interpretation, have some explanation to provide by interpreting what you see in the explanation. So it's not very clear to me if it's explainability of interpretability in some scenarios.
My question would be that how would trustworthiness be improved if we would regularly add confidence to the output? So that the training should be such that if it is derived from effect, then there could be a high confidence score. If it is like a statistical probability, there could be a lower confidence score. Because that's basically how humans speak. So when I think I know that this is something like that, it's very different when I think I guess that it is something like this. And somehow you have to separate of what is like a statistical output for which you cannot guarantee 100%, from something where you actually find some real fact. It's just a question. I don't know whether it is it like introduced anywhere or how it's done. Maybe some time ago it was like popular to add the confidence scores. Now there is less talk about it, but I think that in this case, a lot of new use cases that would be very useful.
Maybe that's related to people working on uncertainty, I think, and uncertainty quantification. And the issue is with those large models, if you don't actually understand how the model works, it's very difficult to produce confidence scores. Because, I mean, it just generates, as an output, it generates a distribution over vocabulary. And there's the added layer of the decoding, which is something, I mean, very simple, but still, you have no way to know what goes on inside. I guess it's related to interpretability, which in my sense is very different from something explainable, because to explain, you do it afterwards. You explain what goes on, and you go trying to find links to the source, to the input, say, okay, maybe this is the input, cause this prediction, but you don't actually try to interpret what the model is doing inside. And in my perspective, maybe that's what it means, is that the user should be able to transparently, by looking at the output and understanding what the model is doing, be able to clearly see the full chain of reasoning. But then that's very complicated in those models, because we would need to actually understand the core mechanics of how the learning happens and have a clear analogy that makes sense to people. So, I mean, from what I see, the best that people are trying to do is sort of use simpler surrogate models, maybe do that, but clearly that's probably not the whole answer to the problem.
Concerning the provision of some confidence scores, from some discussion with it's working on deepfake classifiers. My impression is that the provision of confidence scores as indicators about the trustworthiness of a model should be combined with data about the accuracy of the classifier. So having a 90% confidence that this image is a fake from a classifier that has 50% accuracy, it's useless. So if you have a 100% accurate classifier, then 90% confidence score is something to trust.
And that calibration and calibration requires also condition intensity this 90% maybe.
But there are in fact two benefits to this, because it's an intrinsic where you use whatever's in the model, try to produce a score that's a confidence that probably is very much tied to the accuracy. Then you have an extrinsic aspect where you're saying, okay, some of those things might be hallucinations, others might be factual, where you have sort of an external approach that will look at the outputs and sort of evaluate based on what we know, some knowledge bases, and say, okay, well, this thing is factual, and I can 100% assure the user that it is correct, whereas this thing is completely made up because there was no evidence maybe in some knowledge bases that this actually exists.
So previously, as a user of the deepfake classifier, I'd like to know that this will be very good. This part of the industry strange. I wouldn't be happy to have me learn, machine learning in order to understand why on the tips. I cannot simply. Now it's got to be simple. So this is the way we're going to do it. But for the end user, the information it needs to have is that something to justify the out. Probably in the long run, this could make him being able to identify the fakes of his own more market. But that's what you can do at the end. Haven't both of them. Let's look here and then compile, sort. Let's see that. We have.
Go. It takes time.
Yeah. You want something here? We can continue discussing. Or step with the figure that was designed, but we're doing very good. Yeah. That's how we discuss.
Some reasons that we must hear
Maybe something that we can share probably with everyone here.
Yes.
Yeah.
Yeah, I think perhaps and compile this this information and share.
Yeah. Okay. So let's not waste more time here. We are going to prepare a sort of plan and add this to the workshop.
Yes.
Yes. Thank you very much.
Thank you.